This is Advent of Curry Day 7, and this challenge is called Camel Cards. Your all-expenses paid trip turns out to be a one-way, 5-minute ride in an airship. At least it's a cool airship. It drops you off at the edge of a vast desert and descends back to Island Island. Did you bring the parts? You turn around to see an elf completely covered in white clothing, wearing goggles and riding a large camel. Did you bring the parts? She asks again, louder this time. You aren't sure what parts she's looking for. You're here to figure out why the sand stopped. The parts? For the sand, yes. Come with me. I will show you. She beckons you onto the camel. After riding a bit across the sands of Desert Island, you can see what look like very large rocks covering half of the horizon. The elf explains that the rocks are all along the part of the desert island that's directly above Island Island, making it hard to even get there. Normally, they use big machines to move the rocks and filter the sand, but the machines have broken down because Desert Island recently stopped receiving the parts they need to fix the machines. You've already assumed it'll be your job to figure out why the parts stopped when she asks if you can help. You agree automatically. Because the journey would take a few days, she offers to teach you the game of Camel Cards. Camel Cards is sort of similar to poker, except it's designed to be easy to play while riding a camel. In Camel Cards, you get a list of hands, and your goal is to order them based on the strength of each hand. A hand consists of 5 cards, labelled A, K, Q, J, T, 9 through to 2. The relative strength of each card follows this order, where A is the highest and 2 is the lowest. Every hand is exactly one type, from strongest to weakest. They are 5 of a kind, where all 5 cards have the same label, 4 of a kind, where 4 cards have the same label and 1 card has a different label, Full House, where 3 cards have the same label and the remaining 2 cards share different labels, 3 of a kind, where 3 had the same and the 2 had the different, and then there's 2 pair, where you got 2, 1 pair, where just the highest, 2 pair, where you have 2 cards share 1 label, and then 2 other cards that also share the second label. Then there's 1 pair, where you have 2 cards which share the same label, and then there's High Card, where all the cards have different labels and it's just a single card with the highest number. Hands are primarily ordered based on type. For example, every Full House is stronger than any 3 of a kind. If 2 hands have the same type, a second ordering rule takes effect. Start by comparing the first card in each hand. If these cards are different, the hand with the stronger first card is considered stronger. If the first card in each hand have the same label, however, then move on to considering the second card in each hand. If they differ, the hand with the higher second card wins. Otherwise, continue with the third card in each hand, then the fourth and the fifth. So 3 through 3, 2, and then 2 AAA are both 4 of a kind, but this one is stronger because the first card in the hand, 3, is greater than 2. Similarly, we have this one, they're both a Full House, so then you have to go in order, and then this one has an 8, while this is a 7. To play Camel Cards, you are given a list of hands and the corresponding bid. Your puzzle input. For example, this is the hand, and that's a bid. This example shows 5 hands. Each hand is followed by its bid amount. Each hand wins an amount equal to its bid multiplied by its rank, where the weakest hand gets rank 1, the second weakest hand gets rank 2, and so on up to the strongest hand. This example shows 5 hands. Each hand is followed by its bid amount. Each hand wins an amount equal to its bid multiplied by its rank, where the weakest hand gets rank 1, the second weakest hand gets rank 2, and so on up to the strongest hand. Because there are 5 hands in the example, the strongest hand will have rank 5, and its bid will be multiplied by 5. So the first step is to put the hands in order of strength. This one is only 1 pair, and the other hands are all stronger, so it gets ranked 1. Both of these have 2 pair, but this one, which one is higher, K or T? K is higher than T, so that one wins, and then this one's third. Actually, their first cards both have the same level, so stronger, so that one gets... So this one gets rank 2, and this one gets rank 3. Both of these have 3 of a kind, but then this one has a Q as its first one, so this one is stronger, so it gets 5, while that one's 4. Now you can determine the total winnings of the set of hands by adding up the result of multiplying each hand's bid with its rank. So 7, 6, 1, weakest, so 1 times 1, and so on, so the total winning is 6, 4, 4, 0. Okay, so let's grab the input, put it into here. We're going to make a start off with creating a dictionary containing where is it? The type of cards that you can have. So right here. So let's copy that in. So we'll put that up here. Card types equals, and then we'll give these the values of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we'll start off with iterating through 4 line in input, and what was these called again? So we've got hand and bid, and so we've got a hand bid equals line dot split. And what we'll do is create a dictionary called cards, and we'll do for num for car in hand. We'll do if car not in cards, cards car equals 0. Then we'll do cards car plus equals 1. Then what we'll do cards. So we've now got all the cards that they have and the amount of, well, we have the different types of cards and the amount they have. So what we'll do is we're going to sort the dictionary, so it's from most cards to least. So we'll do sorted cards dot items, and this will be key equals lambda x then minus x1, and need to turn that back into dictionary. So just to make sure that works, print cards. Yep, so as you can see, they're now ordered by how many cards you have of the type. So we're sorting the cards based on first index 1 of it, which is the count of it, and then we're doing it in high to low. So what we need to do now, we need a way to be able to look at these values and determine which one. So the main thing we're doing is comparing them. If we've got like if this person is 2 of a kind, this person is 2 of a kind, then they're going head to head. But if there's ones which is like a 3 of a kind, they automatically go before the 2 of a kind. But then how do we figure out between them which one is high or not? So we have these numeric values. This is the main way that we'll be determining which one's better or not. Because, so if you have A, you have the higher one. So we'll start off with values. Make this a string. For value in cards.value, and we just values plus it equals value. And we'll print value just so we can see what that looks like. Okay, did that wrong. Can only concatenate string, not int. Okay, well, guess we'll turn that to a string then. We did values. Yeah, so that's, we can see that this one has 1 2 of a kind. This one has two of kinds. There's 3 of a kind there. And then, so this is the first part to it for how we identify them. And we'll create a variable called hand type. And as I said, we're going to be using these values here. So what we'll do, this will also be a string. Then for, change the hand types for hand type in cards dot values. Wait, is that the one I want? No, that's not what I want. Wait, what am I doing? That's that one. What I want is the hand. And then hand types plus equals card types hand type. So now let's print hand types, see what that's like. I need to turn that to a string. Ooh, actually. So these are all of different lengths, which isn't quite what I'm looking for. Need to z-fill these. So pattern numeric string with zeros on the left to fill a field of the given width. So we want them all to be a width of 2 because we've got like 10 to 14, but these are only 1. There we go, they're the same length, and you can clearly look at these and know which cards are higher. So 0, 3 is the lowest, 10 is next, and 13 to 12. So we've got this, and what we're going to do is with these two values, we've got games, dictionary, and we're going to do games, and that's going to contain the values and hand types, and then we're going to just store the bit in there. So turn that back into a int equals. So we've got that now. So once we've done that, when we've done all of them, what we need to do is ordered games. So we can use the values within this to order them. So we use the values, which is like, where is it? These numbers. We use these numbers to order it to begin with. So basically all of them are ordered that way. but then any of them with the same of these numbers then get ordered based on this number. So ordered games equals sorted, then this is games dot items, I think, and for this one key equals lambda x, and we are ordering, so we x, then the first index to get the key, or index 0, then index 0 for values, and then we are ordering by the second number, but then we want it from high to low. I think that's how we want it, high to low. I'm not actually sure. Let's take a look at, oh yeah, then we need to turn it back into a dictionary. So print ordered games, what does that look like? Okay, so yep, so this one's low to high because then, so we're then going to iterate through it using the index of 1 to begin with. That will be what this score is, then index 2, this one, etc. So are these correct numbers? They look correct. I guess the only thing you have to do now is total equals 0. Then we do for index value in ordered games dot values, and this should be total plus equals index times value, and then with that we return total. So let's see if that worked, which it didn't. Cannot unpack non-iterable int objects. Oh, forgot to enumerate. There we go. 4 2, is that correct? No, that's not correct. So let's print ordered games and let's compare it so we can find out where we went wrong. So 765 220 28 684 483, or maybe it's index 0, need to do +1 6640. There we go, that's working. So now let's go grab this input, we will chuck it into there and hopefully it works. 246795406. Okay, hopefully that is correct, and it is. Awesome. So we'll now continue on to part 2. Okay, so to make things a little more interesting, the elf introduces one additional rule. Now J cards are jokers, wild cards, that can act like whatever card would make the hand the strongest type possible. To balance this, J cards are now the weakest individual cards, weaker even than 2. The other cards stay in the same order. J cards can pretend to be whatever card is best for the purpose of determining hand types. For example, QJJQ2 is now considered 4 of a kind. However, for the purpose of breaking ties between two hands of the same type, J is always treated as J, not the card it's pretending to be. JKKKK2 is weaker than QQQQQ2 because J is weaker than Q. Now the above example goes very differently. So this is still only one pair, doesn't contain any jokers. This is now only 2 pair, making it the second weakest hand. So these ones are now all 4 of a kind. So this one gets rank 3, this one gets rank 4, and this one gets rank 5. With the new joker rule, the total winnings in this example are 5905. Using the rank of every hand in your set, what are the new total winnings? Okay, interesting. So a couple things first. I need to move this into here. I assumed that it wouldn't change, so I put it up there. And what we need to do, copy this, we will put it here, and we'll just give this a value of 1. Doesn't really matter the position within there. So let's think about how this would work. So I'm going to start off with this, and so this is building it, just so I can see print cards. So we do this, and got the cards. Okay, which one's the values again? Okay, that's the one I was hoping was. If J in cards pass else, we do this. What we can do for highest card in cards dot items, no, this is dot keys, we're gonna break out of it afterwards, And just ahead of time, I'm gonna put this back into here. Cards, highest card, plus equals cards J, and then J equals 0. So we'll, this is values, wait, oh, that doesn't need to be an if statement. It's just, oh, an else statement I should say. This was separate from it. So we'll print cards there and we'll print it here. So this one doesn't change. This one does change. And we keep it like that. Oh, there was that another rule. Did I miss that? Total winnings 5905. Okay, so I've done that wrong. I thought that would have been all that needed to be done. Okay, guess what I need to do now? Print ordered games. Okay, let's open this up and see. So we can see that's 0-1 now for the Joker. We can see it's doing. Okay, I need to reorder it, and then we'll just chuck this below here. 5905. There we go. So if we switch back to this one now and we run it, we got this number here, and we submit it. No, that's too high apparently. Huh. Why didn't that work? So 5905. Oh, there's probably situations where there's the jack is the highest, the joker is the highest. So if highest does not equal jack, then we do this. So that stays the same. I'm gonna just copy this number so we can keep it for reference to see if this change actually fixes it. It is a different number. So hopefully this one is now correct. No, oh, it's too high. But why is it too high? I mean, it looks right. I'm not sure what I'm missing. Okay, so there's something else I'm missing with this. So jacks can pretend to be whatever card is best for the purpose of determining hand type. Is there an input that is just jack, 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 jack? Oh, yes there is. Okay. What we'll do, if the length of cards equals 1, cards A equals 5, and then delete cards J. I want to see if we can actually get to here. Cards highest plus equals. Alright, I meant to break out from there. Okay, how does that number compare? Wait, is one of them even make sense? Okay, what was the number I had before? Okay, how does it compare to that? Okay, it's a lesser number, so maybe that is it. Submit. Too low now. Okay, no. No, I don't think this makes sense at all, what I did there. Okay, so, that's fine. These, both 2 pair. Wait, oh wait, I need to go down here. So this one's the only 2 pair. These ones are now 4 of a kind. Okay, I'm gonna comment this one out. I just want to make sure we are getting the highest one. Print highest and then cards. Okay, we are getting it. And then let's print cards below it. Alright. Don't know if it makes a difference, but probably should be deleting it. No. Yeah, deleting it from there. Does that change anything? It did change the number, but made it lesser. Don't know why that changed it. Cards. Okay, we're going to change it so normal values, and this is going to be for kv in cards.items if k does not equal j v. So what we will do, if length of normal values greater than 0, then we do it in here. Because I feel like it might be that because we're working with the dictionary directly, it might be causing the problem. Because if we're using the list for sorting and stuff, or this type of sorting, I feel like that might fix it. So we'll now go for max count equals normal value max normal values, and then max value equals k for kv in cards dot items if v does not equal j, and oh wait, no, that should be if k does not equal j and v equals max count. So we've got max count, we now got max value, which is this. Wait, no, we want to be getting, so there could be multiple that has the max count. So then with that, we get max value, which will equal maximum for max values lambda x, and what are these called again? Card types x, and want it reverse order. So order those, then you get, okay, I should actually probably print these just to see what it is I'm doing. Get rid of these prints. Okay, I did something wrong. Less than equal to not what? Max value not supported between instances of function and list. Oh right, I forgot. Key equals. My bad. Let's change this for this out. This input. Even though there are multiple. Oh no, that's J. That's why. Is that our own one in A K K 1 1 2 3? What does that one look like? Oh, whoops. Oh, right. Can't have that. Oh yeah, I need a J in that one. So what does this look like? Okay, so okay, that does work. And did it get? It thinks king is the highest. Okay, mustn't need that then. There we go. Okay, we'll remove that. You can see that part's working. We now know definitively what the max value is. So, if normal values is not greater than 0, that means it's all J's. So that means the max value, in this case, that it could possibly change into equals A. And I think, so now that we know what the max value is, we do similar thing as to this. So now it will be max value plus equals cards J, and then we do plus, so this, okay, so no, can't do plus equals in case that doesn't exist. So we do cards dot get max value, and if it doesn't exist, 0. So we've done that. Now we need to sort it again, and then we need to delete the card. So let's, does this do anything? 5905, that was it, right? Have we changed anything here? Has this changed at all? That doesn't look like it's changed. Oh, apparently it did change. Cool. So that is day 6 of Advent of Code 2023. If you like this video, make sure to like and subscribe so you can watch me try and complete more Advent of Code for this year.